All right, good morning. Welcome back to Elements of Calculus 2. We are continuing our little series on the pretest so that you guys are good at figuring out what's going to be happening here. So problem number 5, we have to use Simpson's rule. The formula will be provided for you. Okay, to determine the area under the curve, f of x equals 1 over x cubed. Between x equals 2 and x equals 4, use n equals 4. Okay, so we are going to go ahead and start this problem. I'm going to go ahead and do this. So this is going to be, we need 1 over x cubed between x equals 2 to x equals 4, n is equal to 4. So we can go ahead and figure that out. All right. So yeah, I think I wrote down the formula for this thing, but one of the things that I would like to do is figure out, okay, what's my h? And that's going to be 4 minus 2 over n4. So my h, right, is going to be 2 over 4 is equal to 0.5. If I go ahead and just break this up, let's just double check this. If I look at the graph of 1 over x cubed, something like that, and we're going to start here at x equals 2. We have 2.5, 3, 3.5 to 4. I've got 1, 2, 3, 4 different regions, and is equal to 4. So that kind of makes me happy about what's going on here. I also have the x's I need because we just add h to the previous x and get the values of x that we actually have to evaluate this thing on. So my best choice for this is to kind of make a table, and that's what I did, is to make a table as to what's going to actually happen so that we can keep track of our work and make it neat. Some of you guys on your worksheets did a really good job of having a very neat, easy to follow table. So I get that you get to do that at home. This is an exam, it's a little different, but it is very good for you guys to be able to make tables and display them very nicely, unlike what I'm about to do. So we have 2.5. Leave yourself a lot of room for the fact that these numbers get a little cramped. 3.5 and 4. Okay, again, we're just every time we have an h plus 2 is 2.5, h plus 2.5 is 3, etc. Okay, and then what we're just going to do is say f of x. So all I'm doing is I'm plugging in 2 into all of this. So we have 1 over 2 cubed, which is going to be 1 over 8. Since this is going to be a numeric problem, please feel free to use decimal places. I'm going to say I think 4 decimal places is the standard. If it doesn't say, use 4. Okay. So f of x was 0.125. 2.5 is going to be 0.064. The next one was 0.0037704. The next one was 0.02332. Okay, and the last one is 1 over 4 squared, or 4 cubed rather. 0.015625. That's a little bit more than I really needed, but we have that. The next column I'm going to do is I'm going to put in my weights, because remember that Simpson's rule, we have 1, and then we have this pattern, 4, 2, 4, dot, 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 until we get to the last one, which again is just a 1. So all I'm going to do is multiply these guys across. I'm going to take f of x times my weight. This is going to be w times f of x. So that's all we're doing with this. So this is going to be 0.125, 4 times this. 4 times this is going to be 0.256. Then we have 0 points where I'm talking about like being able to manage your space and make it look like an actual table. So this is 0.07408. Okay. Then 4 times that would be 0.093232. Okay. And of course, the last one times that, 0.015625. Okay. And then, hey, what are we going to do next? We're going to add these guys all the way up. Okay, so we're just going to add this up. I got 0.5663985. Okay, going back to my original idea here, this was b minus a over 3n times the sum of this stuff, right? So we had this giant sum here, right, of all of this stuff. So we're going to have 4 minus 2 over 3 times 4. So that's going to be 2 over 12, which is 1/6 times 0.656, rather, 395. And we'll go ahead and do that calculation. Where did I put that calculation? I got that right here. So I ended up with 0.0939975. And then we'll say, okay, 1, 2, 3, 4. We'll say this is 0.094. And call that good as far as a problem goes. Okay, so you will be afforded the formula for Simpson's for all. I just want to make sure, like, hey, if somebody asks you to do this, would you know how to set? Would you have an idea of how to set this up? Did you practice setting up tables and like dealing with these formulas, just keeping all of your numbers straight, doing all of that stuff? Most of the people in this class are lab students. You guys are very good at making tables and keeping your numbers straight. So I suspect this will be a very nice problem that everybody will get the full 10 points on and nobody will have an issue with it. So, make me proud for you, that make yourselves proud for this one, and have some kind of relief that not every problem has to be the hardest one. And there will be a couple on here that you're like, yes, I know how to do this. Very good. All right. I'm going to sign out. So thank you very much for watching the video. I will see you in the next one. So I'm going to say stop share and end.